Logic gates. So in this number system, so we have four different types. The first one is decimal number system. So then you have binary number system. Then you have hexadecimal. Then you have octal number system. So in decimal number system, so we have a number range from 0 to 9, and in binary number system, so we have only two, that is 0 bit, and you have 1 bit. You have totally 2 here.
Start now.
And in hexadecimal number system, so the number is ranging from 0 to 50. So here in hexadecimal number system, so we have a different encoding method, that is decimal number A, that is number 10. Decimal 10 is represented as A in hexadecimal, and 11 in decimal is represented as B in hexadecimal, and 12 is represented as C in hexadecimal, and 13 is represented as D, and 14 is represented as E, and 15 is represented as F. Okay, so in hexadecimal number system we have numbers ranging from 0 to 15, and in octal number system the number is ranging from 0 to 7. So this is the brief overview of number system. So we have different types of number system, that is decimal number system, binary number system, hexadecimal number system, and octal number system. So in the decimal number system, how do you represent? For example, if you have given any number and you need to identify which type of number system is that. So in order to identify that number system, so we are using this method. That is, for example, you have a number here. Let me say that I will take number 8, or I will take number 7. So this number system, that is 7, is existing in decimal, and it is existing in hexadecimal, and it is existing in octal also. So in order to separate or identify which this 7 belongs to which type of number system, so if I am not specifying any suffix or prefix here, then it is called as decimal number system, and we represent octal number system by this method. That is, if I represent O here, then it is understood that it is an octal number system. And if I represent it as 16, so then it is called as the hexadecimal number system. Or sometimes instead of 16, we can represent H also. Okay, so this is how we will represent hexadecimal number system. Any doubt is there? You can raise. Everyone raise the hand if you have any doubt. So if you need to check whether you are attending the class or not, please raise the hand once. Okay. Okay, we will discuss this number system in detail now. Okay. Now to understand this I will draw the truth table. So in the truth table, so I will, in the first column, I will consider the decimal number system. And the next column, I will consider the binary. And in the third column, I will consider hexadecimal. So I will take the number from 0 to 15. Let me draw this table first. Okay. In the first column, I have taken the decimal number, and I need to represent corresponding binary. So in order to represent corresponding binary, I will take the places. So we call it as a, you can discuss all those things later. So we will take in brief, that is 8421 system. Since I need to represent 4-bit binary, I am taking this 8421 system. And if you are representing 5-bit, then this is 16. Okay. And if you want to further increase it, 16 to the 32, so this is 32. Okay, these are the different places. Okay, now let me consider only the 4 bits. Now, how do you represent 0? Now you can represent 0, okay, by 0, 0, 0, 0. Then how do you represent 1? So we can represent 1 by considering logic high at this place and rest all equal to 0. So I will consider this as 1 and rest all are equal to 0. Then how do you represent 2? So 2 can be represented means I have to consider this place, and this place is logic high, and this place is logic high, and rest all are equal to 0. So 2 is represented like this, 0, 0, 1, 0. Now how do you represent 3? So 3 can be represented like this. So 2 plus 1 is 3. So 2 plus 1 is 3. So I will consider 1 and 1 here, and rest all are equal to 0. Now this is how you represent decimal 3 in binary. So 0, 0, 1, 1. Then I have to represent 4. So 4 I can represent like this. So I have to put wherever 4 is there, consider 1, and rest all are equal to 0. So this is 0, 1, 0, 0. Then in order to represent 5, so I have to consider this bit as high, and this bit should be high because 4 plus 1 is 5. So only this bit and this bit should be logic high, and rest all are equal to 0. So 5 is represented as 0, 1, 0, 1. And the next case, I have to represent 6. So in order to represent 6, so just find out 4 plus 2 is 6. So since 4 plus 2 is 6, I have to consider this is 1 and this is 1, and rest all are equal to 0. So now the corresponding binary for the decimal number 6 is 0, 1, 1, 0. And like this, you can represent 7 also. The 7 means this is 4 plus 2 is 6 and 6 plus 1 is 7. So we'll consider these 3 bits as high and the MSB bit is equal to 0. So we call this as MSB bit and this bit as LSB bit. Least significant bit and most significant bit. The 7 is represented as 0, 1, 1, 1. And you can tell me how we can represent 8 now. See, the 8 can be represented by this binary sequence. That is only this MSB bit is high and rest all are equal to 0. So this is 1, 0, 0, 0. And 9. How do you represent 9? So 8 plus 1 is 9. So 8 plus 1 is 9. So like this. So this is 1, 0, 0, 1 and 10. 10 is represented like this. 8 plus 2 is 10. So 8 plus 2 is 10. This is 0. So this is 10. We are representing like this 1, 0, 1, 0. Then 11 can be represented like this. 8 plus 2 is 10 and 10 plus 1 is 11. So this is 1, 0, 1, 1. And similarly you can represent 12. So 8 plus 4 is 12. So I have to consider year 1 and year 1 and rest all are equal to 0. So this is 1, 1, 0, 0 and 13. 8 plus 4 is 12 and 12 plus 1 is 13 and this bit should be equal to 0. So this is 1, 1, 0, 1 and 14. So 14, how do you represent 14? So 14 is represented like this. 8 plus 4 is 12. 12 plus 2 is 14. So this is 1, 1, 1 and 0. So this is 1, 1, 1, 0 and 15. So 15 is 8 plus 4 is 12. 12 plus 2 is 14 and 14 plus 1 is 15. So the 15 is represented in binary as 1, 1, 1, 1. Okay, so this is how we will convert a given decimal number into binary. And so let me tell you how we can represent this decimal in hexadecimal also. So in hexadecimal, from 0 to 9, the representation of hexadecimal is similar to decimal. Okay, from 0 to 9, representation of hexadecimal number is similar to the decimal number system. So I will represent as it is. And from 10 onwards, okay, from 10 onwards, so 10 in decimal is represented as A in hexadecimal, and 11 in decimal is represented as B, and 12 in decimal is represented as C in hexadecimal, and 13 in decimal is represented as D in hexadecimal, and 14 in decimal is represented as E in hexadecimal, and 15 in decimal is represented as F in hexadecimal. Okay, this is a brief overview of the representation of decimal number system, binary number system, and hexadecimal number system. Okay, now in the further classes, so we will discuss the decimal number system in detail and binary number system, hexadecimal number system, and octal number system in detail and its applications. Okay, thank you very much.
म्यूट क्या कर रहा अनम्यूट म्यूट एम छनी रो पार्टिसिपेंट्स रे विनोद जानू लाल और रेणु मार दी बेटा
And if you have any doubt in this table, you can comment it, or you can and this video will be compressed and shared to you, so you can refer that also, and you can if you have any doubt you can comment and or you can raise the hand.